All right, hello and welcome everyone. My name is Stefano. I work for the Linux Foundation, and this is an introduction to Open Enclave SDK. And I just wanted to go over some quick housekeeping before we get started here. Just so you know, this webinar will be recorded, and the recording and the slides will be made available on our website. Also, there is a question and answer box that you should see at the bottom of your screen. You can go ahead and click on that to ask us any questions. We'll respond to all the questions at the end of the presentation. Yeah, I'll go ahead and pass it off to Ava, who's going to give us a quick introduction of the talk.
Thank you, Stefano. Let's see, could we get the next slide? Hey, so welcome everybody. My name is Ava Black and my pronouns are they and them. I'm the open source program manager for the Confidential Compute team at Microsoft. I'm also one of our representatives to the Confidential Computing Consortium. Next slide, please. The consortium is a nonprofit under the Linux Foundation umbrella, formed in October 2019, focused on a collection of open source projects, securing data in use. And our purpose is to accelerate the adoption of confidential computing through open collaboration. Next slide, please. Our members are a broad collection of cloud service providers, chip manufacturers, and independent software companies, many of which have built open source projects in this space. Next slide, please. And the Open Enclave SDK is one such project. With all that introduction out of the way, I'd like to introduce you to Ming Wei, one of our lead developers, who will tell you more about the OE SDK.
Okay, thanks for the introduction. So I'll just get started. So I'm Ming Wei, as Ava suggests, I work as a software developer at Microsoft. Today, I'm going to introduce you the Open Enclave SDK. Okay, let's start with some background on the confidential computing, right? The goal of it is really to ensuring the security of the data that leaves users' control throughout its life cycle. So such scenarios are not limited to the cloud, although it's currently the main scenario that all the community try to support, but it also applies to other scenarios such as edge computing or IoT devices. So how can we actually achieve this goal? It requires a combination of various technologies. For example, we can protect the data in use with this disk encryption and data in transit with SSL TLS connection. The core and what we are currently focusing today is protecting the data in use with enclaves. An enclave is an isolated memory region enforced by a hardware trusted execution environment, in short TEE. And code and data inside such region is protected by the rest of the system. Therefore, by putting an application inside the enclave which processes data, we can achieve the data in use protection. So give this protection if even attacker that compromise the entire system, or the attacker itself is a system admin or a cloud provider, they cannot compromise the security of the data throughout this entire life cycle. So this is really the goal and concept of the confidential computing. So then the focus today is really how can we develop such enclave programs and take advantage of all these protection provided by the hardware TEE. So first, a developer have to go and create an enclave program. This means loading a binary into this enclave protected memory region from the untrusted host. Normally, this is done by the loader on the system automatically when you invoke an executable, right? But this is not the case for the Enclave because it is more it's a hardware-based specific memory region and it require specific interaction with the low-level hardware and drivers. So we need to instead need a T-specific loaders to help us doing that. And for different type of TEs, right, they will require different interaction, which is involving lots of low-level details, and it will be tedious if we require a developer to deal with all these stuff. Once we loaded an application or binary inside the Enclave memory, the next important thing is to support these high-level language features inside Enclave. So again, Enclave you can think about is a isolated memory region, right? So everything, what you have is what you put inside this memory region. So for example, if you want to run a normal program, you usually need lots of standard libraries installed on system, and it can be shared. So any of your normal application can take advantage of those shared libraries. But this is not the case for the Enclave environment because basically you have to put your own libraries inside Enclave to enable to support all these language features. So this is also require a lot of effort or porting to make things work. And also one important thing is we are really want to enforce or conform the strong security model that provided by TE, right? Everything inside are secure and outside are considered as untrusted. So the way that the code or library porting into Enclave has to conform this model. So for example, we cannot simply put a row pointers inside Enclave that point to the host memories, and that will potentially leak all the data directly outside that compromise the entire protection. So this also requires a careful consideration, design, implementation. So lastly, another really important part is the attestation. This allows a remote party to verify your application are actually run inside the protected Enclave. And in able to support this process, involve lots of it's really like you have to read up what the spec tells you, what is the for example, the evidence format looks like, and how do you generate evidence of an Enclave by interacting with hardware, and on the remote part, how do you verify this specific format, and it usually involves also in different type of crypto operations. So again, it will be difficult for a developer that just want to take advantage of the hardware protection and deal with all these attestation operations. So Open Enclave SDK is here to address all those limitations and help make developer life easier just to write your code, and you can develop an Enclave programs. Open Enclave provide a multi-T support, a loader support that currently support two types of TE. The one is Intel SGX. We also have the preview support of ARM TrustZone. And for runtime support, Open Enclave support both Linux and Windows, and it has a ported C POSIX library based on muscle C, so that you can run any C program inside the Enclave using the SDK. We also Open Enclave also support other third-party libraries like C++, libc++, and TLS SSL libraries. And lastly, for attestation, Open Enclave abstract all the low-level detail and provided plugin-based implementations so that developer can just use those high-level APIs to do the attestation operation for a specific type of TEs. And currently, we support the SGX plugins for the Intel SGX attestation. The architecture of an Open Enclave application looks like this. So we respect to the typical TE model, where there is a normal world and an untrusted world and a trusted world, TE. And the Open Enclave is really sit between the low-level components and the high-level applications, so that we can abstract all the low-level details. The host runs on the normal world is only responsible to bootstrapping an enclave. This is based on the host libraries provided by Open Enclave. And Open Enclave provides a self-contained runtime support, and all the runtime are in the enclave boundary, which are sufficient to support a normal C and C++ program. So again, for function that's not available inside enclave, for example, is a rather restrict environment. For example, all the syscalls may not support it inside the enclave. So for that case, the Open Enclave will still make a call to the host, but we also ensure all those boundaries are done in this secure manner. Okay, this illustrates how, at high level, how an Open Enclave application works. So the host program take a binary, an ELF binary, as an input, and it is signed by OE provided tool, which injects some enclave specific information that will be understood by the OE loaders. And the host program can use the API to create, by putting this enclave binary as input, and create an enclave, which load the binary inside the enclave. And also, we provide a way for a host to invoke the function that is implemented inside by the enclave program. That we call echo. And also for enclave, there's a way for an enclave program to invoke function defined by the host, that is through an OCO. Okay, so we will have like high-level model on how the host and enclave interact with each other, and in the following slides, we'll go through more detail on how an application on OE looks like. So this is a minimum application you can create it using OE SDK. So as we can see, the host and enclave code are in the separate directories that are responsible for host and for enclave program separately, and they are compiled separately so that you can clearly see where the boundary is. And we have a EDO file, which we'll explain in the next slide, that define all the boundary functions that can be called, even including the echo or OCOs. And there we show there's a C code and a hello world underscore U and hello world underscore T. C. Those are really the boundary code by our tool using an EDO, so that you will clearly see what are the potential functions that can go across the boundary. Other than that, there shouldn't be any code that accidentally go across the boundary. Okay, this is an example of how an EDO file looks like. as I said, this is really to define all the boundary functions that your application may use. The trusted section define all the eCode that can be called by the host. And the untrusted section define all the O-codes that can be invoked by the Enclave program. So each application is associated with at least a single EDO, but you can also use the import syntax to import multiple EDO. For example, some Open Enclave by default provides some EDO that for make develop experience easier, and you can also define your own EDO file that import by the main EDO file. Once we define EDO and generate the edge routines, then next is just going to the program development phase. So in this case, we have the host program that define an O-code host_hello world, and Enclave define an E-code, the Enclave hello world. So the host is just like a normal C program, right? It implements a main function which can be built into a executable. So in this case, the main function takes an argument which expected to be the path to the Enclave signed binary. And the host used the OE create API to create the Enclave. And after the creation, the host can use the boundary code to invoke the function defined in the Enclave. In this case, is the Open Enclave, the Enclave underscore hello world. And after all the interactions, the host can call the terminate OE terminate Enclave to deallocate the Enclave, release the Enclave memory. So as you see, these are looks really just like a simple, normal function code, right? There's no surprising thing evolved after, at least in this model. But what behind the scene is more complicated than simply a function code, right? We explain what actually happened when the host invoke the eCode. So after call the Enclave underscore hello world, the host routine will go, which is defined by the edge routine, will serialize the argument, and then at this point transfer the execution to the Enclave. So know that because Enclave is a protected memory region, and the host cannot access any data inside the memory region. So only the Enclave side can access host memory. So it's always the Enclave who takes responsible to do the data transfer. So in this case, it is host invoke the eCode, but it's when execution transfer to the Enclave, and the Enclave will copy whatever on the host into the Enclave memory, so that we can ensure do the boundary check, and host cannot directly send whatever access the Enclave memory. So after Enclave get the arguments passed from the host and do any synthesized check, and then it will finally reach the point to invoke the eCode implemented by the Enclave program. And after the execution, it will similarly copy any return value back to the host, and then at this point transfer the execution back to the host. So the O-code, the mechanism is similar to the eCode. It's just done in the reverse way. So let's see, when in this case, it is the Enclave who call a function on the host, which is the host underscore hello world. So now the Enclave will serialize the argument and copy the buffers. Again, the Enclave will do the memory copy. Enclave copy the buffer into the host memory, and then at this point, transfer the execution back to the host. So, and host will do similar things to get what argument passed by the Enclave, and then is there any return value? You will use a similar way to transfer back to the Enclave. So note that the return value for the local case, right? The return value from the host is not trusted anyway, because in the thread model we consider host is not trusted. So developers should always take extra care when they're using an OCO. Okay, so next is the remote attestation support. We are not going to much detail, but at really high level, OE support the SGX plugins and provide a high level APIs. The OE get evidence and verify evidence for one to implement these remote attestation operations. So in this diagram, we'll show an example of an Enclave program can use the get evidence API that talk to the SGX components to get the evidence of the Enclave program. Then the Enclave program can send this evidence to the endpoint, and the endpoint can be a attestation service, and then use the OE verify evidence API to verify whether the evidence is correct or match what you should expect to be. There are more features we are not covered in this presentation. For example, we have more APIs that we are currently support. And then we have, for example, we have a simulation mode that allows one to try their Open Enclave program without hardware support. We also have a lot of tooling support on for both Linux and Windows debuggers and IDE integrations, so that you can use existing IDEs and develop an Enclave programs. And we also have a package manager that we will detail a little bit in next few slides, that for a user to get more libraries run inside Enclave. There are also more features that either in our planned or unplanned that we are thinking we can add in the futures. So because we are the open community, we are more than welcome to take any feedback and keep improving the project. So, okay, well, now explain a little bit more on what is the package manager, APKman. So recall Open Enclave currently the package shipped with a limited set of third-party libraries. We support, for example, we support the muscle libc and OpenSSL and libc++ libraries, but that's really a few set of libraries. If a user or developer want to use more libraries with Open Enclave that write their application inside Enclave, then typically they have to work the flow is they have to manually download the source code and do a manual lots of porting job to make sure everything just work within the Enclave, and then build on the library so that they can use the library inside the Enclave. This is not what normal. If you are familiar Linux user, you are more familiar with the second workflow is you just use the apt-get, for example, the apt to install whatever package you want and do the install. Then you can get all the resolve all the dependency. Then you can just write your program using headers, using the libraries. But this is not the case for Enclave, because we emphasize that Enclave is a rather restricted environment. Everything is like what we put inside of it. So the APK man is trying to solve this problem, reduce the gap on supporting a more libraries into the Enclave. So this is what the work APK man looks like. It's actually a simple, rather simple self-contained script that is based on the Alpha in Linux package manager APK. The key points on this design is it is because Open Enclave, the libc is also based on muscle C, and which the Alpha in Linux distribution is also based on the muscle libc. So it brings up a nature compatibility between each other. So we provide a wrapper on the APK command that allow us to grab the packages from the Alpha in Linux packages, and then we can directly, mostly likely use the static library that depend on the muscle C provided by Open Enclave. Here we'll show a little bit demo on how the user experience looks like. Oops. So here we have a typical application, want to use in a protobuf, and we define the data structure that we want to use to serialize. So this is the EDO defined in this Enclave program. As you can see, there is only one in the trust section, which is the equal that will be invoked by the host. So this is what a simple host program looks like. It's pretty much like what I showed in previous slide. It invoked the OE create API to create Enclave and invoke the Enclave test equal that defined by the EDO. So this is what on the Enclave side program looks like. We have one single C++ source file, and we also have we pre-generated the protobuf dependency, this .cc and .h file that are generated by the protobuf defined that was shown in the beginning. So this is really what the Enclave program looks like. We define the Enclave test equal, and as you can see, we use a bunch of these protobuf APIs, and now we are go ahead to build the Enclave to see what happened. Okay, we are go and make. Now you can see there's an error. Show okay, the header is not found because now we haven't installed the package yet. So with that, we can just simply use the APK man and use the command to add the dependency that just like a normal workflow. So now we add the protobuf dev packages. And now because all the dependencies are installed, and so it's problem resolved. And we can start just running the program that using the protobuf libraries. Okay, so what is Open Enclave position in the ecosystem? So now, if you start looking into this space, there are already lots of SDKs that help achieving the similar goal to develop an application that take advantage of the TE protection. For the Open Enclave is really, we posit it as a TE abstraction that sits between a low-level TE components and the high-level application code. For one workflow, for one model, if user really care about security, they want to build a minimum enclave program with minimum TCP. That is more from the ground up approach. You put only the security critical code inside the enclave and write a program from scratch. Pretty follow what I just showed. For example, you use the APK main flow. You use the library and write your own code that using the library. So that is what you write is the only thing that will be put inside the enclave. For the rest, that is sit in the untrusted normal world. The other direction is supporting people may want running more general applications or more high-level applications that just take advantage of the entire hardware protection. In this case, OE also allows you to allows people to build a high-level framework on top of this or Open Enclave T abstraction layer. So this including we currently support several high-level framework that is built on top of OE, including the Confidential Consortium Framework, Edgeless RT for supporting Go application, and also the SGX LKL Mystikos that take a libOS-like approach to support unmodified application. So this is Open Enclave also enabled in that direction. So this high-level framework don't need to deal with the low-level T interaction, which are handled already by the Open Enclave. Don't need to do the duplicate job. Just focusing on the high-level feature support. So we'll show one use case, which is the Mystikos, that use a libOS-like design that supports the application with lift and shift approach. So it supports both either a native or containerized applications. So for abstract targets, you can see in the graph, it used the Open Enclave for the abstract support. Okay. We'll show a little bit demo on how what Mystikos can enable. So you may want just like run a Python script and just use inside the confidential world, right? Then in this case, just a Python, and we have a Docker file, and you want to containerize your Python program. So we simply can use this tool command provided by Mystikos to build a Docker image. And after build the image, it's pretty straightforward. We'll just go ahead, create a root file system, and use the command to execute the Docker. So yeah, you can see now we basically run the same Python script, but all the execution are happen inside Enclave. So this is kind of what this high-level framework can provide you. You can directly take advantage of this approach as well, and empowered by Open Enclave indirectly. How's it getting involved? So definitely go and check our GitHub page and follow. We have lots of documentation, and you can just follow and try to write your own programs. And we are really in the open source community, so we are really welcome for anyone who want to contribute by either reporting bugs on GitHub or ask questions, provide any feedbacks. If you want to get involved more deeply, you can or want to contribute some code, you can search the issues with a good first issue label and submit the pull request, and we will more than happy if you do that. And we have we have many open meetings. Basically, all our meetings for Open Enclave are open, and feel free to join into the discussion as well. And we may also form more SIG group that to get more interest. People who are more interested can involve more. So with that, this will conclude my talk, and I'd like to take any questions.
Thank you for that great talk, Mingwei. We've got two questions here. I'll start with the first one. What does Open Enclave provide to strengthen the security of enclaves against side channel attacks? For example, are there tools to ease the development of constant time calls or set up other protective measures? Are there samples that show how someone could do this, or good practices when developing an enclave using Open Enclave?
Sorry, I lost my video. Can you say the question again?
Oh, sure. Can you hear me now, Mingwei?
Yes, I can.
Okay. What tools does Open Enclave provide to help a developer strengthen the security of their Enclave program against side channel attacks?
So side channel attacks, we always consider this side channel attack in our OE. So what we does is more on the build default settings, right? We always use the secure default compilation flag. So for example, all our OE provided libraries are built with the speculative load hardening flags provided by CLAN. We also not encourage you to not using GCC, which does not provide similar support. And for example, we also support we also ship the LVI mitigated package specifically for people who are more conscious about the side channel attack. They can use those mitigated libraries. So this more on our libraries level instead of tool level, because that has to be enforced at the compile time.
Okay, thank you. We've got another question here, which I'll actually take a stab at answering. When we run the entire application inside an enclave using Mystikos, how does that help protect against untrusted code? It doesn't secure the supply chain, right? Whatever application you're wrapping up in the demo that Mingwei showed, that's what's going to run in the enclave. But the boundary is protected. So that application, that workload, whatever data you access, is not accessible to the host or to anything else on that machine from outside the enclave. The next question I see is, can I try out Open Enclave on a dedicated computer with SGX, or do I need to use a cloud service like Azure? Mingwei, to you.
No, okay. Well, yeah, you definitely can run any Open Enclave on any SGX capable machines. That is not, we're not Azure specific. We have the workflow also that work for the non-Azure native environment. So that definitely, the answer is definitely true. Yes,
Yeah.
you can.
Are there some, I'll add on to that for clarification.
Yep.
Anyway, are there some components or capabilities of Open Enclave, like attestation, that might be limited without using a cloud service?
I think so. We have the interface for you to use. Definitely, we have the interface for you to use Azure attestation service, but it's not limited to that. You can also use the Intel attestation service. It's more like a plugin or the API decision you can make. So we are not forcing the policy on that part, because it is a SDK. You can write your application and use any underlying mechanism.
Great, thank you. Next question, what plans do you have to improve DCAP attestation IAS API? The requester says, currently it looks like you're based on Azure DCAP v1 or v2, but Intel PCCS 1.9 no longer supports those.
Yeah, I think we're actually working on that. We have a plan on the upgrade in the next few release. So it's work in progress. We definitely have a plan on that.
Cool, thank you. And I'll just echo one of Mingwei's closing slides of like, if anyone wants to come work on this or help improve support for a version or integrate some other attestation service, we love pull requests.
Well, thank you very much, everyone. Appreciate everyone attending, and thank you very much to Mingwei and to Ava for the presentation. And as I mentioned, this will be posted on the website, and an email will go out also notifying you when the recording is ready. So thanks, everyone, and enjoy the rest of your day.
Thanks, everyone.